photosynthesis. Hey! Alright guys, so let's start off with photosynthesis. Now, whenever I teach photosynthesis to my students, I also try to teach respiration one time. Because to me, the two topics are kind of tied into each other. But anyway, let's go into it and you'll see how they're tied into each other. First of all, photosynthesis is how plants make food. And the type of food they're trying to make is something called glucose. So let's see how the plant goes about this. Well, the plant will take carbon dioxide, add water to it. Once it has these two, it will take sunlight, and once 1, 2, 3 mix together, I'm using that term lightly. So once these three mix together, the plant will get two things: glucose and oxygen. Okay? Now remember, the glucose is what the plant actually wants. It just so happens it also creates oxygen. Now I know oxygen is a good thing for humans, but please remember that the plant doesn't need the oxygen. So to the plant, this is actually a waste product. Believe it or not, that's actually a waste. Okay, so what questions could the examiner ask you on photosynthesis based on what I just told you here? Well, one popular question in the exam, they like to ask, what is one of the waste products of photosynthesis? And the answer would actually be oxygen, because the plant doesn't actually need oxygen. Another way they could bring that question is to say, what gas is produced in photosynthesis? Remember, this is a gas produced. So the answer for that would be oxygen. If they ask you what gas is needed, now hear the word, if needed for photosynthesis, carbon dioxide is what is needed. Oxygen is what is produced. So when you're doing the questions, especially the multiple choice, look for those words, right? Waste and produce is oxygen. Needed gases, well, the needed gas is carbon dioxide. All right. So another question that I found comes really popular in the exam. After the plant mix 1, 2, 3 together and it gets glucose and oxygen. Remember, glucose is what the plant actually needs. Now, glucose is a type of sugar, right? Now, let's say that it's just like human beings. Sometimes you have food, but you don't want it right away. So let's say somebody gives you a pizza and you don't want to eat it right now. Obviously, you're not going to throw away the pizza. You might put the pizza in the fridge or store it away for when you actually need it. A plant has a similar process. Let's say glucose was just produced and the plant doesn't feel like using the glucose at this point in time. What it will do, it will store it. But when it stores the glucose, it doesn't store it as glucose. It stores it as something called starch. And this is a very popular question in the exam. And it's very popular amongst teachers that bring it in the multiple choice. So if they ask you, what is glucose or what is plant food stored as, right? The answer is starch. And this is how it works. When the plant stores the starch, right? If it needs food again, it will go to the starch and convert it back to glucose. And once it's back to glucose, the plant will use it. All right? So I covered quite a lot of questions they can bring on photosynthesis. So how is photosynthesis and respiration tied in? Well, let's look at the formula for respiration. And just in case you don't know what respiration is, it's how living organisms produce energy. Because we all need energy. Even you. Like, even to watch this video, it takes a lot of energy. For you to run or to even while you're sleeping, your heart needs to beat, your brain is functioning, you need energy to do all of those things. So how does a living organism, inclusive of plants, produce energy? Well, It takes glucose, it adds it to oxygen, and once you mix these two together, you get carbon dioxide and water and energy. The main thing here is energy. So this is what you actually want in the respiration. So we want it here. So in respiration, you want energy and you actually get energy. But you notice when you mix glucose and oxygen, you get three things: carbon dioxide, water, and energy. Only two is actually needed. Only one is needed and two is not needed. So guess what? The carbon dioxide is a waste product and the water here is also a waste. Well, the H2O is a waste product. So what will happen is that you notice in photosynthesis and respiration, right? In photosynthesis, the waste product is oxygen, but in respiration, the waste product is carbon dioxide and water. Anything that is waste, the plant or any living organism will need to get rid of it. So how does a plant get rid of its waste products? Oxygen, water, and carbon dioxide. Because remember, these two processes, photosynthesis and respiration, are happening inside of the plant. So here's a very popular question. How do they get rid of those waste products? Well, how do plants get rid of gases? Well, the gases we're talking about here is oxygen, carbon dioxide, and the water we're talking about here is water vapor. Underneath the leaf, there are small holes called the stomata. So all the waste products goes out of the stomata. So that's a very popular question for people who are preparing multiple choice questions. Okay, so that's how plants get rid of its waste gases. Okay, through the stomata. If you didn't know that, make sure and rewind the video and take a note of that. All right, so what do we have so far? Oh, I wanted to show you the link between photosynthesis and respiration. The plant produces the glucose, and remember, respiration needs glucose. So the same glucose from here will go over here. And once we get the glucose here and we mix it with oxygen, well, respiration will take place. Another question that can come in the exam: where does the respiration take place? Well, this goes back to cell theory. Okay, so let me just pull up a quick note here. All right, so in the cell, you know, when you have plant cells, right, there are a lot of things inside here, right? There's the nucleus, there's the vacuole. If in the exam they ask you, where does respiration take place? There's a component of a cell called the mitochondria. That's why I have trouble spelling. So M-I-T-O-C, too little bit of space here. M-I-T-O. Think I spelled that correct. I'm double checking. Right? Nobody's perfect, right? Okay, so that's a really popular question in the exam. Where does respiration take place? I agree it happens in a cell, but they're going to be more specific. They will want to know which part of the cell it occurs. Okay, so I think we covered quite a lot of questions there. All right, another thing a lot of people don't know. Let's get rid of these extra. Okay, well, we know respiration is how they produce energy, and we have waste. Let me get rid of this here. All right, I want to show you something. It deals with nighttime and daytime, and the type of gases that are being excreted by plants. Okay, let's take during the day, right? So let's say we have a tree or a plant and it's daytime. Keep in mind, for photosynthesis to occur, you need sunlight. And once something is living, whether it's waking or sleeping or it's daytime or nighttime, it needs energy. So respiration is going to be a big part of the organism staying alive. So during the day, there's sunlight available, so the plant can photosynthesize, and it's living, so respiration will take place. So during the day, the plant will be photosynthesizing, tight down there, and respiring. So during the day, you can expect oxygen to be coming out the plant, and also carbon dioxide, CO2, and H2O. Well, I'm not too focused on the H2O, but I'm still going to put it in. So during the daytime, the plant is excreting oxygen and carbon dioxide and some water. However, during the night time, when there is no sun, so there is no sunlight, the plant cannot photosynthesize. So during the night, it needs to stay alive still. So it will be only doing respiration. So during the night, there will be no oxygen coming out of the plant, only carbon dioxide and water. Okay, and this is another popular type of questions. If you go through your past papers, they love to test these things. So if they ask during the daytime what gases to expect coming out of the plant, this is your answer. If it's in nighttime, what gases you expect to be coming out of the plant, this is your answer here. Right. If they ask you what are the common gases during the nighttime and the daytime, well, during the nighttime and the daytime, these are the two things you can always expect coming out of the plant once it's alive. Okay, so I think I hit all the well, hopefully I hit most of the questions that comes in the long paper and the multiple choice regarding photosynthesis and respiration. Oh, one more thing. Just off the topic of plants. Remember, I stated that when a plant wants to get rid of its waste, well, its gases, it does it through the stomata. But how does a living organism like a human? A human has respiration going on inside of it, right? So during respiration, you get carbon dioxide and water. But how do we get rid of these gases? We don't have stomata. These gases are taken from the cells via the blood and it goes into our lungs. And once it reaches into our lungs, we breathe it out. So when we breathe out, you can expect carbon dioxide and water vapor to be leaving the body or excreting it. That's how we excrete carbon dioxide and water that's made during respiration. All right, guys. So I really hope this covered a lot for you all. So we're going to move on to our next topic and explore the type of questions the examiner can ask you. And guys, please don't forget to make notes. If you forget something, if you're making notes throughout the video, it's going to save you a lot of time, because if you forget something, you have to rewind the video or find the correct spot in the video. As soon as you learn something new, pause the video, write it down. You can put it in scrap writing, and when you get time in the night time or whenever, you can write it back neat. But have those scrap notes. That is what you're going to use to revise. Okay? All right, guys. Next topic coming up. Topic 2: electrical energy calculations. Alright guys, so let's get to the next topic. This one here, it's really popular in integrated science in the exam, is electrical energy calculations. Now, this topic was requested by someone called Brent. So you all can blame Brent for this video. Okay, so first things first. When we're doing electrical energy calculations, electrical energy is measured in kilowatt hours. Capital K, capital W, common H. To calculate the amount of electrical energy in kilowatt hours, we have to take the amount of kilowatts, don't worry, I'll explain this kilo just now, and multiply by the time. But the time has to be measured in hours. And that's a key trick in the exam. They will give you the time in days, minutes, possibly seconds. And you have to remember that you need to convert the time to hours. So there's one formula to calculate the electrical energy, the amount of energy used, or they can ask you to calculate something called the cost. For example, in your house, you use electrical energy, and at the end of the month or every 2 months, you have to pay a certain amount of money. So to calculate the cost, you notice that the kilowatt hours and the time in hours is the same. So it's the same formula from above. You just have to multiply it by the time, but by the cost of each kilowatt. That's the only change to this formula. So don't worry. So basically, this formula is the top formula. So I'll put it in brackets with one extra step. You just have to multiply by the cost of 1 kilowatt hour. And in different countries, the cost for each kilowatt you use is going to be a little bit different. So the examiner will have to give you the cost of each kilowatt in the exam itself, right? So it will be somewhere in the question. But anyway, I'm going to do a ton of examples, so you're going to get a hang of it. All right, so one of the most requested questions is how you read analog electrical meters. So I'm going to do 2 examples here. Let's say that the top is an electrical meter, and we had read it on one day, and then we came back the day after, which is the underneath one. And of course, by the end of the day, we will have used a certain amount of energy. So let's see how we read it. So to read analog meters is really, really simple. The rules are simple. Most of the time, so as far as I know, for every question I've seen, the needle itself it's never actually on a number. It's usually in between a number. And what you need to do is take the lower of the 2 numbers. Okay? So I'll keep reminding you of that. Except when it's between 0 and 9. Whenever the needle is in between 0 and 9, once it's in between the 0 and the 9, I know 0 is the lower number. But when it's between 0 and 9, you choose the 9. That's the only exception to the rule. So let's read the amount of kilowatt hours in the top one. So in this one here, you'll see the needle between 1 and 2. You have to choose the lower of the 2. So we're going to choose the 1. Then in the next circle, it's between 3 and 4. We have to choose the lower of the 2. So I'm going to choose the 3. In this one, it's between 0 and 1. 0 is smaller than 1. In this one, it's between 8 and 7. So we're going to choose the 7. And the last one is between 0 and 9. This is the exception. When it's between 0 and the 9, we choose the 9. So this is the amount of kilowatt hours for the reading on top. Let's just do one more just in case. So the one underneath, right, is between 3 and 4. So we're going to choose the 3. That's the smaller. Look over here, it's between 0 and 9. When it's in between 0 and 9, we choose the 9. Okay? Over here, it's between 1 and 2. So we choose the 1. Over here, it's in between 2 and 3. So we choose the 2. And this one between 6 and 5. So we're going to choose the 5. So that's the amount of kilowatt hours for the underneath one. All right? So let's assume that this here is the reading one day, and then we came back another time and we reread the meters. If the examiner were to ask you how much energy was used, how much electrical energy, we just have to minus the before and after readings, and that will tell us how much electrical energy was used in between that time. So if in the exam, whether it's the long paper or the multiple choice paper, they give you a question like this, and that's very popular, you read the meters properly and then minus the 2 values. So I'm going to minus these 2 and see if I can get the actual answer here. 3, 9, 1, 2, 5, minus 1, 3, 0, 7, 9. When we minus it, we get 26046 kilowatt hours. So for this household or whatever or business, this is how much kilowatt hours was used. And if it's a multiple choice, you might see this in between A, B, C, and D. All right. So this is the amount of kilowatt hours. Easy enough? Great. But they could take the question one step further. They could ask you, what is this person's bill? How much they might have to pay? Well, for that, to calculate the cost of using this amount of kilowatt hours, remember, we have already got the kilowatt hours. Remember, the amount of electrical energy, in the brackets here is electrical energy, right? And to find the cost now, we just have to take the kilowatt hours and multiply by the cost of 1 kilowatt hour, right? The amount of kilowatt hours by the cost. So let's assume that the cost of 1 kilowatt hour is 25 cents. All we have to do is take this value and multiply it by 25 cents. So if I take this and multiply by 0.25, we will get the big bill though. $6,511.50. All right. So remember, when you use this meter, so when you use the analog meter, the reading is automatically in kilowatt hours, right? And to get the amount used, you minus the before and after situation. And to get the cost, you take the kilowatt hours and multiply it by the cost of 1 kilowatt hour. All right, so let's do some other examples that doesn't involve the analog meter. All right, so I'm going to leave this on top here. I'm going to assume for all the questions, the cost of 1 kilowatt hour is 25 cents. Obviously, in the exam, it could be $2, $3, $4. It could be different things. So here's the questions I prepared. And each one has a trick in it. In each case, we want to calculate the cost of using these devices here. Right. I think the only one that doesn't have a trick here is the first one. So let's go through it. In the first one, we have an electric time machine. And the power it uses is, well, remember this formula is electrical energy. Electrical energy is the kilowatts. Believe it or not, kilowatts is the power. So you're already taking the power and multiplying by the time in hours. But the power has to be in kilowatts. So to calculate the cost for the first one, right, I need to take the amount of kilowatts. Did they give me the power in kilowatts? Yes. So it's 800, no trick. Then we have to multiply it by the time. The time has to be in hours. So the time is given in hours. So, and now we have to multiply by the cost of each kilowatt, which is 25 cents, which is my assumption for this question. So to calculate the cost for using the electric time machine is 800 multiplied by 5 multiplied by 0.25. And it's $1,000, right? So it's $1,000 bill. But like I said, this one is easy. I don't think you'll get this one in the exam. It's too easy. I would never bring this in the exam. Let's try the second one. The other one is an electric vomit stopper. So this time they gave you the power, but they gave you it in watts. For this formula to work, it has to be in kilowatts. To convert watts to kilowatts, kilo means 1,000, you have to divide it by 1,000 first. So that's the power in kilowatts. Now we have to multiply by the time in hours. Lucky for us, it is given in hours, and the cost of each kilowatt hour is 25 cents. So we just need to work this out. 5250 divided by 1,000 multiplied by 3 multiplied by 0.25, and it's a very small bill. It's just $3.94. All right, guys. Now in the exam they're going to give you nicer numbers than this, right? Because in the exam, if it's a multiple choice, you're not going to have a calculator. But these are questions I just made up just to show you the procedure. All right, so you saw the trick in that one. In the third one, the electric fly juicer, the power is given in watts. We need the power in kilowatts. So that's 600. We're going to have to divide it by 1,000. Multiplied by the time in hours. they gave me the time in minutes. To convert minutes to hours, we have to divide it by 60. And now we're going to multiply it by the cost of each kilowatt hour, right? Cool. So 600 divided by 1,000 multiplied by 15 divided by 60 multiplied by 0.25. This is a very small bill. It's actually just 0.0. Well, if you round it off to 2 decimal places, it will be 0.04, which is really 4 cents. Okay, so this is a very small bill. I just double checking my answer, guys. I want to make sure I'm giving nothing wrong. By 1,000. Yep, it's correct. Okay, so the little tricks here is when you're calculating the cost, make sure it's in kilowatt hours and the time. Now, if they ask you just to calculate the electrical energy, remember, you're going to use this formula, which is this formula without the cost of each kilowatt hour, right? So read the question carefully, whether they want you to calculate electrical energy or they want you to calculate cost. Very common mistake made by students in the exam. So be on the lookout for that. All right, guys. So on to the next topic. Well, I guess the sensei will introduce the next topic. Take care. Lesson 3. Forces and moments. Hoi! Alright, guys. So let's get to lesson 3 here. Now, the first thing I want to really clarify is that force is something measured in newtons. Symbol is capital N, right? Weight and mass is not the same thing. It's something I have to go over and over and over with my students until it sticks in their head. Weight is actually a type of force. So if weight is a type of force, then weight will also be measured in newtons. Mass, on the other hand, is completely different. Mass is not weight and hence not a force. Mass is to be measured in kilograms, okay? And here's the formula that relates mass and weight, right? Weight, you just block the item you want. Weight is mass multiplied by gravity, and weight is mass multiplied by gravity, and mass is weight divided by gravity, right? And gravity on Earth is going to be 10. So especially in the multiple choice, they like to bring questions on simple things like mass and weight. So there's a quick example. Let's say I tell you the mass of something is in kilograms, and you know it's mass because you see the units here to be kilograms. To calculate the weight is just mass multiplied by gravity. So if I had to calculate the weight, it's just the mass, which is 45, multiplied by 10. So the answer will be 450 newtons because weight is measured in newtons, right? And in the other hand, if I had something with a weight of 500 newtons and I wanted to know the mass, well, mass is just weight divided by gravity. So I would take the weight, which is 500, and divide it by gravity, which is 10, and get 50. But my units will now be kilograms. All right. So it's really important that you know the difference between a force, a weight, and a mass. Okay. Because when it's time to do the calculations, right, it's going to make a big difference. Okay. So one of the first questions I'm going to do here is a moments question. And well, remember this tutorial session is not a session where we're going to explain everything from scratch. It's going to assume that you know some of the basics, and I'm here to reinforce those basics and show you the tricks they can play on you in the exam. All right. So if you're interested in having a full tutorial, like a complete tutorial on force, weight, and mass, you could just go on YouTube, type in iLoveLessons space and forces, right? And you just type that in, and the first video that's going to come up is going to be the tutorial explaining this from scratch. Okay, all right. So here we have a seesaw, right? And we have a circle and a square. The mass of the circle is 50 kilograms and the mass of the square is 80 kilograms. And this is 6 meters from the center or the pivot. And we are trying to find X to make the whole situation balanced. Okay, so what's happened, the theory that we're going to use with it is the moments on one side is equal to the moments on the other side. Well, to be more specific, the anti-clockwise moments is equal to the clockwise moments. So first things first, a moment is the force multiplied by the distance. Now there's two ways to get the correct answer here. One of them, believe it or not, is the wrong working. Imagine the wrong working is going to give you the correct answer. So I know some of you are saying, right now, are very concerned about the multiple choice, and the multiple choice, you don't really care. They're not going to see you working. But suppose it was the other paper now, the paper 2, where you had to show your working. It would make a difference. So I'm going to work it both ways so you get an idea. So the force by the distance on one side is equal to force multiplied by the distance. The anti-clockwise moment is equal to the clockwise moment. So I'm going to do it the wrong way and get the correct answer. So here's what some students do. They see 50 here, so they put 50 and the distance is 6 is equal to the force, and they put 80 and they multiply by the distance, which is x. And we just simply solve for x, right? So we multiply these two and divide it by 80. So 50 multiplied by 6 divided by 80. And if we work this out, right, like we multiply these two and then throw across this, we get x to be 3.75 meters. Now let me explain why this is wrong. Okay, let me explain why. The formula says force by distance. That's how you calculate a moment. Remember, a moment is a turning force. So 50 kilograms, remember, mass is not a force, right? Mass is not a force. So you are taking something which is not a force, which is mass, and you're multiplying it by the distance. And of course, believe me, this answer is correct. But because you mixed up, like, by doing this, you are effectively telling the examiner you didn't know that mass wasn't a force. So you are assuming that mass is a type of force, which is a really big error in science. Okay, so how do you go about this question to get the actual correct answer? Well, first of all, you need to convert this to weight. And remember, weight acts vertically downwards. So 50 kilograms. Weight is mass multiplied by gravity. So we're supposed to take the mass, which is 50, and multiply by gravity, which is 10, and it will give us 500 newtons. The weight on this side, remember, weight is a type of force. I know I keep saying it over and over, but I'm going to continue to do it to annoy you so it sticks in your head. 80 multiplied by gravity is 800 newtons. So the force by the distance on this side is equal by the force on the distance on the other side. Great. So the force here is 500 multiplied by the distance, which is 6. And the force here is 800 multiplied by the distance, which is x. So if we multiply these two and throw across the multiply to get a divide, and we work this out, we will still get the 3.75. 500 multiplied by 6 divided by 800 is 3.75. Like I said, both ways we get the same answer. Multiple choice, it won't matter. You're going to get it correct. But if this was the long paper, you would have gotten it wrong. Right? And I explained the reasons behind that just now. Okay, so I wanted to make sure you could do these types of questions for the exam. Another thing I want to go through is the different classes of levers. There's class 1, there's class 2, and there's class 3. And you won't believe how much students forget what's a class 1, class 2, and a class 3. And I don't think if I ask any student to come up with a way to memorize it, no one usually has an idea. But I was bored today, so I came up with I hope it's a good way for you all to memorize it. So give me a few seconds to draw the different classes of our levers, and we'll discuss them. 1 second. All right, guys. So let's just discuss the three different types of levers, three classes. First of all, E is for effort. That is what you are applying. The load L is what you are trying to move, right? And well, the P is the pivot. By now you should know what the pivot is. And well, the pivot and the fulcrum is the same thing. So I'm going to use E, P, and L. In a class 1 lever, right? The pivot is in the middle. The effort and the load are on either side. Okay? So for class 2, the pivot is to the end, and the effort and the load are elsewhere, but the effort comes first and the load comes second. In other words, the load is the one in the middle. Okay? And in class 3, the pivot is to the end, right? And the effort is the one in the middle this time. All right? Now, I gave you some examples of each one. The class 1, look at 3 examples here. Class 2, the wheelbarrow and the nutcracker. Class 3, the biceps and the tweezers. Now, you can easily Google proper diagrams for each one of this on by just typing in class 1, class 2, class 3 levers and go to images on Google. And you'll see really good diagrams just popping up. Now, I wanted to give you all a way to remember this, right? So, a good way to remember it is it's a way to prolong your health, or to make you healthier, or how to live longer, right? So here's what I came up with, right? The first lesson in living a healthy life, or to prolong in your life, is eat plenty lentils. That's the first lesson. Second lesson, eat less peas. Hence, life expectancy is prolonged. Okay? It's the best I could do, right? So eat plenty lentils, eat less peas, life expectancy will be prolonged, right? So I hope that will help you remember the class 1, class 2, and class 3, because it's a common problem. And usually when kids do multiple choice exams, or even the structured ones, and they ask you to draw diagrams of each one, the majority of students, they forget. So, and one small thing I wanted to cover is something called the mechanical advantage, right? Very popular question in the multiple choice. Mechanical advantage is the load divided by the effort. Okay? Now the load goes on top, and load and effort are forces. So make sure the load is in newtons and the effort is in newtons. I'll give you a really good trick, a good trick question they can play on you, right? So it deals with the class 2. Remember, a wheelbarrow is a type of class 2. So let's say we have a wheelbarrow here, right? Try my best to draw this little wheelbarrow here, right? So you have a wheelbarrow and we have some sand in it, right? So that's a little sand there. Obviously, for you to lift this, you're going to lift on this side. So let's say you apply an effort of 500 newtons. And the examiner tells you that the weight of the sand is 20 kilograms, right? So this is your load, what you are trying to move. So let me show you the trick they will play on you. They ask you to calculate the mechanical advantage. Cool. So you know the load is 20 and you are applying an effort of 500. So you will say 20 divided by 500 is, well, the answer for this is 0.04, right? Mechanical advantage doesn't have a unit. And you will get it wrong. Let me explain why. You have the effort correct. The effort is 500 newtons. But your load, they gave you it in kilograms. Kilograms is mass. Mass is not a force. and mass is not measured in newtons. You have to convert this to weight. So you have to multiply by gravity, which is 200 newtons. Weight is measured in newtons because weight is a type of force. So it's really 200 divided by 500, and the answer would be instead 0.4. So don't fall for those little tricks. And I've actually seen like teachers bring multiple choice questions where they ask you for the actual formula for mechanical advantage. It's just load divided by effort. Alright guys, so I really hope this was helpful, and the next topic, well, Sensei will introduce it. Topic 4, series, parallel circuits. Hooey! Alright guys, so I'm going to look at series and parallel circuits and like try to show you all the different questions that can come in the exam, especially for the multiple choice. First of all, right, when it comes to circuits, right, there's 4 things you basically want to be paying attention to. One is, well, let's write a little more space here. Well, voltage for sure, right? Voltage is measured in volts. You have current, right? And current is measured in amps, right? Or amperes, that's the actual correct term. There's power, which is measured in watts, and then there's resistance, and resistance is measured in ohms, right? So I actually have seen questions come like this in the exam. They will ask you, what is voltage measured in? What is power measured in? Right now, watts is W-A-T-T-S. Ohms, let me spell it out for you just in case, is O-H-M-S, right? And voltage and amperes, I'm pretty much sure that by now we could spell those. All right, so here I have two circuits. This is a series, right? The best way of explaining the series, you could think of the line as a river, and there's only one river here. A parallel, you'll notice when the river is flowing, it splits into 2. It could also split into 3. So a parallel is when there's more than one rivers, right? Series is just one river. But that's not the main thing. I'm pretty sure you knew that already. These here represent bulbs, right? Bulbs or lamps, right? And you know the purpose of a lamp is to glow, and some lamps will glow bright and some of them will glow dim. So I have a question. What determines the ultimate brightness of a bulb, right? Is it voltage, current, resistance, or power? What determines the brightness? Very popular question in the multiple choice. Brightness is determined by power. So make a note of that. Brightness is determined by power. Okay. So another question they can bring is, right, in which of assuming that each lamp here, 1, 2, 3, 4, they're all the same brand of lamps or bulbs. In which scenario will the lamps glow the brightest? Will the brightness be greater in the series, or will the brightness be greater in the parallel? Make a note. In parallel, the lamps are brighter. So parallel will give you brighter lamps. Make a note, and guys, these are official exam type questions. All right, make a note. Okay. All right. Another question is, in series, right, both lamps, right, there's a current coming out. Well, the symbol for current is the letter I. In series, both lamps have the same current, right? So in series, they have the same current. So if the current here is 5 amps, the current here will also be 5 amps. However, well, assuming that they were different lamps now, right? If they were different lamps, they would still have the same current. But in series, they will have different voltages. Okay? Voltage, sorry. So that's one thing you need to know about a series circuit. Usually in a series, everybody experiences the same current. But usually, I mean, in this case here, if they were the same exact type of lamp, they would get the same voltage. But if this was a different brand of light to this one, they would experience different voltages. Okay. In the parallel, it's the opposite. In a parallel, provided that these are two different brands of lamps, okay, they will experience different current. So in this case here, in parallel, they have the opposite, different current. Sorry for the abbreviation there, but I don't want to write over here. But they will have the same voltage. So the abbreviation there. So make a note. In series, they have same current, different voltage. In parallel, they have different currents, but same voltage. All right. So that's two things covered there. Whenever you want to measure the current, you use something called an ammeter. That's to measure current. Hence, well, ammeter and amperes. You can see the relationship there. If you want to measure the voltage, you use a voltmeter, obviously, because it's voltage. Whenever you are connecting an ammeter, you have to make sure it's in series. Right? The symbol for ammeters, capital A with a little circle. So the ammeter has to be in series. If you want to measure the voltage across this lamp, you have to put it in parallel. All right, so that's another popular type of question. Like they will draw like 4 diagrams, A, B, C, and D, and they will connect the ammeter and the voltmeter in different arrangements. You have to choose the one where the ammeter is in series and the voltmeter is in parallel. For example, if I wanted to measure the voltage across this lamp, I would have to put a voltmeter across it in parallel. And if I wanted to measure the current through this one alone, I would put a ammeter in series with it. Okay guys, so that's basically a lot of the different types of questions they can bring on series and parallel circuits. So hope I'm not forgetting anything, right? Discuss the brightness and everything. All right, so it's only actually there's a 5th topic I want to do now, right? But it's how I say, it's not me drawing on the board exactly. It's some slides that I made about 2 months ago, and it was going to be on animal and plant cells. Okay, and this is all the necessary, all the key points you need to know in order to get almost basically all your multiple choice questions correct based on animal and plant cells. All right, so give me a few seconds to organize. You will see the slides popping up on the screen, and I'm going to be talking in the background about them. All right, a few seconds. Topic 5, animal and plant cells. Hoi! All right guys, so as promised, let's start off with the different slides here. Right now, this is the part where you need to get your books out and your pens out and start making notes. Believe me, these notes are really summarized and they have all the key points. All right, so slide, I need to keep track of it here when I'm editing the video. Slide 1. Okay, the first thing they might ask you is, what is the definition of a cell? And they might put 4, well, even in the long paper, right, they might ask you this to write it out. But they could also ask you, they might put 4 different choices, A, B, C, and D, and you're going to have to choose the correct one. So what is a cell? A cell is the basic structural, functional, and biological unit of all known organisms and the smallest unit of life. It can also be called, there's another definition, they are often called the building blocks of life. All right, so that's the first thing. So hope you take it on. Let's move on to slide 2. All right, it's by now, well, one of the first topics you would have ever done in integrated science in school is the plant cells and the animal cells. Now, your teacher would have mentioned that there are some things that are similar to both the plant cell and the animal cell. So if you look at the diagram, the slide here, in the middle, that's the intersection region. Those are the things that are common to both the plant cell and the animal cell. So the nucleus, the mitochondria, the ribosomes, the cell membrane, the cytoplasm. Now, you'll see the Golgi body in brackets because that's not on the integrated science syllabus. So, you see everything in white in the middle. Those are things that are common to both plant cells and animal cells. Okay? Now, there are certain things that can only be found in a plant cell. So that's to the left in green. Things like the cell wall, the large vacuole, the chloroplast. Those are things that strictly belong to the plant cell only. And there are certain things that only belong to the animal cell, which is, if you look to the right in a kind of orange there, animal cells have a small vacuole, right? Now, plant cells, right, have a large vacuole, right? So, one second here, guys. So, plant cells have a large vacuole, but the animal cells have a small vacuole. Some textbooks actually go the length to say that an animal cell doesn't have a vacuole at all. I am sticking with they have a small vacuole as opposed to a large vacuole in the plant cell. Alright, so next thing, slide 3. Terms that you will hear over and over, right? Protein synthesis, right? What is protein synthesis? Now, you know protein is something that you need to build muscle. So there are three basic things. Proteins, carbohydrates, and fats. So the carbohydrates is the one that gives you the energy. Protein is for muscle building or muscle growth. But what is protein synthesis? It's very simple. Everything is made up of building blocks, like Lego blocks. Protein is made up of smaller parts. These smaller parts are called amino acids, which is a very popular type of question in any multiple choice exams. They might ask you, what is the building blocks of protein? And the answer for that is amino acids. Now, if you have building blocks, you obviously need to put them together or stack them together to get protein. The act of putting together these amino acids is called protein synthesis. So protein synthesis is putting together amino acids to create the proteins. So protein synthesis is basically the creation of proteins from smaller parts. Right, respiration, that's the second item. We went through that already. That's the production of energy in living organisms. Photosynthesis, we covered that already, so I'm not going to go through that. 4. Alright, so often in the exam, you're going to hear ask for definitions of diffusion and osmosis. Diffusion, the movement of a substance from an area of high concentration to an area of low concentration. Osmosis is a special type of diffusion, but it's only for water moving across a semi-permeable membrane. Alright guys, that's one of the first things we have learned, probably in Form 1. So take it on. Now there are two types of processes. One called passive and one called active. Passive. Passive means it will occur naturally. You leave it alone and it will happen. So an example of passive is diffusion or osmosis. Diffusion, if you have perfume, like you spray perfume in one corner of the room, without you doing anything, without you fanning it or trying to push it, the perfume molecules will spread across the room. That's passive, meaning that you don't have to do anything for it to play out. It occurs naturally. Active, you have to actually give it energy in order for it to happen, right? So know the difference between passive and active. So next down is the next slide. This is slide 5. Okay, this is the general function of each part of the cell: the cytoplasm, the nucleus, the cell membrane, mitochondria, ribosomes, vacuoles. And slide Well, take that down. Make sure you take it down and learn it off. This is as simple as you can get it, right? I already took the notes and I summarized it here, and I put the easiest language I could have used. Slide 6 is just a continuation. In this one, I'm explaining what the cell wall is and what the chloroplast does. Okay? So pause the video, take it down. And the last one is 7. How things enter or leave cells, right? So if you have a cell, you have to control what's coming in and what's going out, whether it's an animal or a plant cell. So things can enter or leave by passive or active. Remember, we discussed passive and active. Passive, you don't have to give it any energy for it to happen. Active, you will need to give it energy. So they love to ask you in the exam for examples of like passive and active. So here are some examples of passive transport. No energy required. Diffusion, right? Oxygen and carbon dioxide can leave cells via diffusion, and that's passive. Osmosis can enter or leave cells without giving it extra energy, and that's passive. So, but passive transport occurs from high to low concentration in the direction of the concentration gradient. That basically means I'm going to use oxygen as an example. The oxygen can only move from areas where there's plenty oxygen and naturally move to areas where there's a lower or less amount of oxygen. Okay? And active transport in cells is something where there's one called the sodium-potassium pump. You just need to know it. Honestly, in the syllabus, you don't have to describe it. They might just put it as a A, B, C, or D choice, and which one of these is an active transport in cells. So the sodium-potassium pump is one of them. And another example of active transport in biology is how minerals enter or leave the root hairs of a plant. This is plants. You know when plants have their roots into the ground, water can enter through the roots, but minerals can also enter through the roots. Water enters by osmosis. Osmosis is passive, but minerals enter the roots not by osmosis and not by a passive method. It enters by an active method, which means that the plant has to invest energy to get minerals into the roots. All right. So active transport occurs from low to high concentration against the direction of the concentration gradient. Okay, guys, so learn off these definitions and learn off the examples. And I'm telling you, you see these 7 slides in front of you? This is basically the answer I'm telling you to about 8 or 9 questions in a general multiple choice exam that a teacher would give you. Okay? So learn it off, guys, and I really hope that this entire tutorial session was helpful. This is not the last one. This is my first one, and I'm going to do more, right? So every time I'm going to pick a topic, I might repeat topics. I might repeat photosynthesis and introduce other questions they could possibly ask you. And of course, guys, if you have anything you want me to explain, like something giving you real trouble, WhatsApp me. My number can be found in the description. Explain to me what kind of problems you're having, so when I'm doing my next video, I could probably put it in, and it will make my life easier, so I will know what to teach. All right, so now I just want to talk a little bit about the little exam, how I plan to do all the integrated science videos. In the description, you will see a link for a multiple choice exam. Okay. All the questions are based on exactly what I just taught in this video. So here's what I want you to do. Go to the link. Don't use your notes. Revise for it and everything first. Do the 10 questions. Click submit. When you click submit, it will autocorrect and give you a score out of 10. Okay? As to make it fun, only if you get 10 out of 10, I want you to take a picture of it. If you want, obviously, everything here is optional. And send me a picture of your score, and if it's really 10 out of 10, I will send you your first grading belt, a white belt. All right. So I just let you know, just a picture of a white belt. It's not a real white belt. Okay, guys. So have fun, and of course, don't forget to share and subscribe, and of course, like the video. Take care, guys.